All right, folks, we are going to get into 6.4 and 6.5 today. I'm going to do them together. It's going to take a little bit of time, but you'll be through two sections. What we're going to do is look at the sine and cosine function again. And I know in the last section we looked at just the basic sine and cosine function and how they behave. Now we're going to look at how we can alter those. We can transform them like we can any other function. We're going to look at when we stretch them out, either vertically or horizontally, or if we shift them left or right. And there's a purpose for this. What we like to do with these sine and cosine functions is model things we see in nature a lot of times, or different processes that we can, or we want to try to mathematically describe, things like the rising and falling of the tides, things like your change of seasons, the temperatures. We can actually create equations to model these things. And in order to do that, we first need to understand how we can change and alter these sine and cosine functions. So we're going to do that. I'm going to stop talking about that and head over, and we'll just start working on it. Excuse me. So now what we're going to be doing is looking at this function with all the different ways it can change. So what I'm going to do is start out by drawing this out. If it'll allow me to write, there we go. Y equals plus or minus A. A is just a constant here. And then we're going to have, I'm going to put sine in here, but this could be cosine. It works the same way. And then we're going to have another constant, B. And bracket around that. Then inside here, theta, plus or minus another constant, C. And finally, our final constant, plus or minus D. All right, so we're going to take these one at a time, guys. We're going to look at each one of these constants and what they do to our function. All right, plus or minus is, I'm going to start, I should probably start there just because it's not something I'm going to spend a lot of time on, because it's the same as it is with any other function. If you had a negative x squared, it reflected it across the x-axis. The negative still does that. A negative in front still reflects it across the x-axis. All right, it's going to do the same thing. And we'll see what that looks like as we go through this. All right, so that's going to reflect it across the x-axis. But I want to deal with A. When A is a value other than 1, we are going to see some changes. So I'm going to go to a new page that we're just going to label what happens when we have y equals A sine theta. All right. So what's going to happen to our graphs and things of that sort? All right. So we need to, I need to open up. I need to get some graphs here. Just one second, guys. Okay. All right. So getting back to this, sorry. If we had something, for example, they gave us that said, I want you to graph y equals 2 sine theta. Well, what happens here is we want to look at what would happen to the graph of that. All right. So what I want to do is I want to plug in one of these graphs, and I didn't want to do that. Let's do this. Let's make this a little smaller so we can work with it a little easier. There we go. All right. There you go. I like that. All right. So what are we going to do with this? If we again go to that unit circle that I showed you with the sine and cosine graphs before, and we go back around and think of what is sine. All right, sine is the y values. So sine as we go around this unit circle is going to be 0, and it's going to be 1, and it's going to be 0 again, and it's going to be -1, and it goes back to 0. So what's happening here? This is the sine of theta. We're just taking twice that value. So when I'm at 0, what is twice 0? It's still 0. When I go to 1, I do 2 times 1, sine of pi over 2, right? This is at pi over 2. So sine of pi over 2 is twice that now. It's up here. When I get over to pi, pi is back at 0. Go down to 3 pi over 2. At 3 pi over 2, negative 1 becomes negative 2, right? We're down here. And then back to 2 pi. 2 pi is 0 for sine. Twice that is still 0. So our graph of this function now would look like, oh, my graph is really bad. I don't like that at all. Let's do it again. I got to get better with this. Just like I tell you guys, you got to practice. All right, that's much better. Okay, so we have this graph. This would be a representation of y equals 2 sine theta. Now, what's happened here? What's changed? Well, we talked about the period of this function. And the period is when it repeats itself. This is going the same as it was before. The period is 2 pi. We didn't talk as much about something called the amplitude. We talk about the amplitude by definition, and let's write this over to the side. Amplitude is going to equal your max value minus your minimum value divided by 2. All right, max value minus minimum value divided by 2. So in this case, 2 minus negative 2 is 4, right? Because 2 minus a negative is plus a positive. So 2 minus negative 2 is 4. Divided by 2, I get 2. My amplitude is 2. All right. Another way of thinking of this is the axes of our function, right? It's the center point of this function. And another way people think of amplitude is from the axis to its high point or the axis to the low point, what is that distance? All right, both are good explanations of amplitude. The strict definition is max minus min divided by 2. All right, that's a distance thing. You take the distance from the top to the bottom, divide it by 2. That is going to be your amplitude. All right, so what is the amplitude now? The amplitude is 2. What was the amplitude of our basic cosine function? Remember, it went from 1 to negative 1. So its amplitude was 1. So what does the A value do? It tells you your amplitude essentially for sine and cosine because their normal amplitude is 1, and this is a multiplier of it. So it becomes the new amplitude. It tells us how much further it goes away from that center point. All right, so one example of that. To do another one, let's just do another one in another color so we can just do it right on this graph. If I wanted to, again, do another example, say y equals, let's do a negative just so we can talk about that for a second. Let's do negative 3 cosine theta. All right, if I do negative 3 cosine theta, period. Well, we haven't talked about anything changing the period yet, so nothing has. It's still going to have a period of 2 pi. And in terms of the amplitude, well, amplitude is not going to be a negative 3. It's going to be 3. What does the negative tell us? Because of the negative, we know that we have to reflect across the x-axis. All right, so let's look at what happens with that. So now let's look at our unit circle real quickly. And if we did cosine, cosine here would be 1, 0, negative 1, 0, and back to 1. So normally I'd be starting at 1. At 0 radians, my value is 1. So I do negative 3 times that, I would go down to negative 3. So now this cosine, instead of starting how it normally started at 1 at its top, it's going to start all the way down to negative 3 at its bottom. The negative reflects it over the axis. The next value is 0 at pi over 2. So negative 3 times 0 is still 0. At pi would have normally been negative 1. And now we have negative 3 times that, so it becomes 3. Whoops, I didn't move over. All right, so at pi, it's 3. And then at 3 pi over 2, it's 0. Negative 3 times 0 is still 0. And finally, it's going to finish where it started at 2 pi. It's going to be down at negative 3. And so we would get this graph. Remember, notice on the red one, I already drew my arrows at the ends because this does go on forever. We're just drawing one period of it. And that's what I expect as your solutions, is one period of the graph. All right, so that's our negative 3 cosine graph. Y equals negative 3 cosine. Amplitude was 3, period 2 pi. It's reflected across the x-axis, so it would look like that. All right, so that's our A value. If we want to write what that is, the A value then is going to change the amplitude. If you want to, you could say by a factor of A. Right? A is multiplying it, so it's going to become A times that. And most our sine and cosine are one amplitude, so it's A times 1. So it becomes A as the amplitude. So it's going to change the amplitude. All right, let's go to the next one. This B value. All right, if we want to look at the B value, all right, let's look at what happens with that. Let's go to another page. That would be something like this. Y equals, let's do sine of 2 theta. All right, and again, I'm always going to go back to this thing. All right. I want to move that down a little bit. There we go. And our unit circle. Everything goes back to this unit circle always, guys. And sine, when we were talking about sine, we're dealing with 0, 1, 0, negative 1, 0, right? So if I want to graph this, all right, my amplitude looking in front, my amplitude is unchanged, right? Amplitude is still 1. What's going to happen to this thing is going to happen in terms of its period, all right? So let's look at that again. Let me just get us another grid. All right, so we've got this here. Now I want to look at what's going to happen to our graph. Excuse me. If we start at 0, all right, our value input for theta is 0. If we have 0, it's at 0. All right, but first I got to plug it in here. Twice 0 is still 0. Sine of 0 is still 0. So sine is going to still start here. It's at the same point. When I get to pi over 2, all right, with pi over 2, what's going to happen here? Well, let's look at this. If I talk about pi over 2, that's here. But if I take 2 times pi over 2, what happens? 2 times pi over 2 puts me here, right, at pi. So sine of pi was 0 again. So at pi over 2, I'm back at 0. Well, okay, so now if I go to pi, what happens? Well, pi becomes 2 pi, right? Because 2 times pi is 2 pi. Sine of 2 pi is 0 again. Well, how is this my graph? Well, think about what happens in these in-between points. If I have pi over 4 and I plug it in, 2 times pi over 4 is what? That's pi over 2. So that's where I get my 1. My 1 is actually right here. And I would need to be at 3 pi over 4 to get twice 3 pi over 4, 6 pi over 4, or 3 pi over 2. So that's where I get my negative 1. So we end up with a sine graph that has one full period, one full cycle in pi radians. So what happened to the period? The period became pi. All right, so how do I find period? Well, period is going to be, I call it the old period. You could call it original, however you want to think of it, divided by b. So our original period of cosine was 2 pi. If I divide that by my b value of 2, I get pi. All right, that's how we find the new period. All right, so let's do another one of these. Let's move down. I'm going to give you a new grid. We're going to do a whole new one. All right, I'm going to show you how to do one that has a little bit of everything in it. I can keep doing that. All right, so let's do another one. Oh, there we go. All right, so if we had y equals 2 sine, well, let's do a cosine, just because we haven't done one of those. 2 cosine of, let's do 1/2 theta. All right, so what is my amplitude here? My amplitude is 2. My period is going to be, well, the original period was 2 pi. I'm dividing by my b value of 1/2, and I would get 4 pi. So now the way I do this is it's a little bit different than what I've been showing you with the circle, but it works on the same premise. If you remember those circle values, what I like to do with this is I make a little grid for myself where I know normally I'd be going 0 to 2 pi, right? This would be pi, this would be pi over 2, and this would be 3 pi over 2, all right? We know our normal values for this, again, if you think of that unit circle, our normal values for cosine. Cosine is the x value, starts at 1, 0, -1, 0, back to 1. So this would be 1, 0, -1, and 0, and back to 1, right? That would be the normal values. But what do we have to do? We have to think about that's where they would normally be, but we have a change in our period. Our period is now 4 pi. So instead of going 0 to 4, 0 to 2 pi, what I want you to look at is now I'm going to be going 0 to 4 pi, right? And 0 to 4 pi means 2 pi is my center. Pi is the halfway point between there, and 3 pi is the halfway point between these. So now, this is what I'm going to mark my axes with. I'm going to say this is 0, this is pi, this is 2 pi, 3 pi, and 4 pi. All right, and I know because my amplitude has changed to 2, the high point is going to be at 2, the low point is at -2. So now I draw, oh, I'm sorry guys, I'm talking and not looking at what I'm writing. 0 we know is here, pi, 2 pi, you were jumping out of your seat saying, why would he put 0 there? Good for you. All right, so we got this. So what are our values? We said we start, it would have been at 1, now we're going to be starting at 2, then we go to 0, then we go to -2, back to 0, up to +2, and we get our 1 transformed cosine function. Arrows at the end. Oh, my arrow did not want to draw there. All right, so we get this. Again, you're going to see we're going to keep adding layers to this, but that's what B does. B changes your period. So let's go back to our original thing here and say this changes period. How does it change the period? Well, we know that our new period is going to be equal to the old period or original period divided by B. All right, so that's going to work every time. All right, so now what are we going to work on? Well, let's work on C. Inside a function, what it always happens when we had something like y equals the absolute value of x plus 2, that moved it left and right, right? Same thing here. All right, let's go to C values. If we have something like y equals sine of theta plus pi. All right, what's going to happen here is the same thing we saw happen with our other any other function we translated. Inside the function like this, if we have a plus, it's going to move left. If we have a minus, it moves right. So this is going to change what we call a phase shift. All right, so let's go through our stats for this one. Amplitude. Well, the amplitude, there's no a value, so we consider it to be 1, right? Period. There's no b value to alter it, so our period is still going to be 2 pi. And now we have what we call a phase shift. All right, the phase shift is when we move left or right. In this case, we're moving left pi. So now what is that going to do? Well, again, I'm going to make that little grid I just talked about in the last one. And normally I'd be 0, pi over 2, pi, 3 pi over 2, and 2 pi. And again, if we think of our unit circle, and I'm just going to sketch it really fast, for sine, we know this is 0, 1, 0, -1, and back to 0. All right, so that would have been 0, 1, 0, -1, 0. The period and amplitude haven't changed. So the amplitude decides these numbers, right? The period hasn't changed. It's still 2 pi. It's doing this, going 0 to 2 pi. So it's going to be every pi over 2. The difference is we're starting left pi. So we're subtracting pi from this value. We're going to start out, instead of at 0, we're going to start out at negative pi. So I just subtract pi from every one of these. This would be negative pi over 2 because we have pi over 2, or 1/2 pi minus 1. 1/2 minus 1 is -1/2. Here we'd have 0. 3 pi over 2 minus 1 is going to give me pi over 2. 2 pi minus pi is just pi. All right, so that's what we're going to mark our grid with. So let's get one of those. Let's move this down and let's draw this graph now. So I start with these values. I know I'm going to go 2 back and I'm going to have negative pi, then negative pi over 2, then 0, and pi over 2, and pi. All right, so this is the way it's going to look now. So how high is it going? Well, it's going only an amplitude of 1 and -1. So we have this. Now we can start to fill in the blanks. We start at 0, we go to 1, we go to 0, -1, and 0. And we can draw our sine function that has a new phase shift. This allows us to move these graphs left and right. Before we were changing how high they went, so their max and min values. We were changing how fast they went through a cycle. Now we're changing left and right. All right, let's look at a combination one. Let's look at an ugly one. All right, let's do y equals -2 cosine, and let's do 2 theta minus pi over 2. All right, so in this, what happens? Amplitude. Our amplitude is still 2, or is now 2. I see the negative, and right here you might want to just say, you got a reminder that it's reflected across the x-axis, right? That's what that negative does. Period. Well, our period was 2 pi, and now we've got a b value of 2, so our new period is pi. And phase shift. Our phase shift is right pi over 2. Okay? So, how are we going to graph this? We just quit right now, right? We're building on this little by little, guys. We're going to have a few days to practice this, so don't worry about getting nervous about how this sounds. If it makes it look difficult, I'm going to give you a lot of examples today. We're going to take a little bit of time with this video and make sure you got everything you need. All right, so we've got this set up. So again, if we talk about doing, whoops, I need my right marker. If I do this, I know normally I'm going 0, pi over 2, pi, 3 pi over 2, and 2 pi. All right. I know also that this is a cosine function, so cosine is 1, 0, negative 1, 0, back to 1. So this would be 1, 0, negative 1, 0, and back to 1. All right. We have a negative, so these are all going to become opposites, right? So now this would be negative 1, 0, 1, and negative 1. All right, so opposites of all those. We know we've got a period of pi now. So I'm going to go from 0 to pi. So that means if I wasn't shifting it, these would be my values, right? I have to break it into half of that, and then halfway between that, right? 0 to pi. Now, the problem is we also have a shift. Our shift is right pi over 2, so it's adding pi over 2. So we're going to start at pi over 2. 1/4 plus a half is 3/4. A half plus a half is 1. 3/4 plus a half is 1 1/4, or 5/4 pi. And 1 plus a half is 1 1/2. So these are going to be the values I use. So with this, I'm going to be starting my graph at pi over 2. The next value I have is 3 pi over 4. The next value is pi, then 5 pi over 4, then 3 pi over 2. What are my values? I have, again, it would have been negative 1, 0, 1, 0, but I've got to multiply it by 2. I'm going to be going as high as 2, as low as negative 2. So you could have actually multiplied all these right off the bat, made this negative 2, 0, 2, negative 2 if you wanted to. So I'm going to start at negative 2 and at pi over 2, right? Negative 2, then 0, then 2, then 0, then back to negative 2. So again, this little worksheet here that you're making for yourself over on the side can make this a lot easier. But this is what we'd be looking at. We've got our graph. All right, last one. We've got the D value. All right, so what does that do? Well, let's write down here what C did. C is our phase shift, right? Plus moves it left, minus moves it right. All right, and finally, we are going to look at D. What does this do? All right, so let's get ourselves a new page and look at one that has y equals sine theta plus 1. All right, so again, if we go here, our sine is 0, 1. I don't like that line in there. That is 0, 1, 0, negative 1, and back to 0. All right, so what's going to happen? Well, what happened with the x squared function when you added 1? The entire thing moved up 1, right? Same idea here. Remember I talked about in that first pane, I talked about the axes being this x-axis? Well, now this is going to move that axis up. So I still go through all of this stuff. I always make sure I know everything is right. Amplitude, 1, no reflection. Period. Period is, there's no change in it, so it's 2 pi. Sine. Phase shift. There's nothing in the inside the function, so it's not theta plus or minus inside parentheses. So phase shift is going to be 0. This is what we call a vertical shift. They sometimes also ask you for the new axes. All right, the new equation of the axes, I should say. All right, the vertical shift is up 1. the equation of the new axes would be y equals 1. All right. So what that's saying, and I usually start with this because I always want to see where my axis is first. So this is my new axis. All right. It goes across at 1. It's up 1. Now, everything else is going to stay the same. My normal 0 to pi over 2 to pi to 3 pi over 2 to 2 pi is still going to stay in effect. Sine is going to still start at 0, but think about that. At 0, I would have 0, but then I'm adding 1. So it's starting at my axes now. Instead of at 0, it's at its axes, its midpoint, so to speak. That's another thing, the equation of, what do they call it? There's something they call with midpoint too. There's a lot of different things they call this when we talk about, I just ask you, is it up or down? Up 1. So 0, it goes up to 1. Pi over 2 is normally 1. That's going to go up to 2, right? So our high point is now 2. Our low point is 0. So we're going to go to our high point. This is a sine function. Back to our middle. Down to the low point. Back to the middle. You're going to hear me go through this a lot because I kind of shortcut it that way. Well, that was not well drawn, but you get the idea. All right, so that is our sine function. All right. So what does this do? I'm going to go back here real quickly, and then we're going to do some ugly ones. This changes our axes, right? Plus moves it up, minus moves it down. All right. So let's do a couple other examples, and then I'm going to get you started. And I understand, guys, the first time you try this, they're going to look ugly. And the answers in the book, I'm going to tell you, the solution manual does not give you a lot of good answers. I'm going to draw all these for you, one translated period or transform period, the next day. Tomorrow, when we go over this, I'm going to draw them for you. But let's look at some other ones. Let's do this. Let's do y equals 5 cosine pi over 2 theta. You know what? I'm going to draw this differently so you see it, because the book sometimes does this. It's kind of mean, but they do this. They'll write this one this way. They'll do 5 cosine pi over 2 theta plus pi minus 1. All right. Notice this is in a different form. Right away, first thing I do is I change it. I factor out that pi over 2 so I see the true shift. This is just like you do with anything else. I want to see that true shift. So this would be dividing by 1/2. I would get twice that, so 2 pi. All right, that's the way we're going to look at it. So now we can say our amplitude. Well, our amplitude is 5, right? Period. Well, period is, well, normally we would have 2 pi, but we've got pi over 2 multiplying. So pi over 2 underneath, what does that give me? Well, that's equal to 2 pi over 1 times 2 over pi, right? So what would we end up with? Just 4. That's 4 radians. That's okay to have just 4. It doesn't have to be in terms of pi. 4 radians. Period is 4. That's it. Now, phase shift. Our phase shift, this tells me, the factored version tells me I'm going left. Oh, I'm sorry. This wouldn't be 2 pi. It'd just be 2. Caught myself there. This is just 2. Sorry, guys. Losing my focus. So it's left 2. And vertical shift is down 1. All right, so now we got to put all this into a graph. Let's try this. All right. Now, I'm going to do that same thing I did before. I'm going to start and try to figure out what this is all going to look like. Normally, I'm at 0, pi, 2 pi, and I'd be at pi over 2 and 3 pi over 2. Now, I know for cosine, this would have been 1 0, -1, 0, 1. Now that's going to be multiplied by 5, right? So this is going to be 5, 0, -5, 0, 5. So we're going to go as high as 5, and I'll just mark that up here. Well, that's not really done yet. All right. We have a new period of 4 radians. So now instead we'd be going from 0 to 4. All right. Just 4 radians, 0 to 4. So where would be the midpoint? At 2, this would be at 1, and at 3. So we would just literally have 0, 1, 2, 3, 4. But not so nice to us again. What did it tell us about the phase shift? The phase shift is left 2. So I have to subtract 2 from each of these. So this is -2. This would be -1. This would be 0. This would be 1. This would be 2. So these are the things I'm going to mark on my axes, right? These are the coordinates I want. And the only thing we haven't dealt with is it's down 1. I didn't write the 1. Down 1 changes this. I have to subtract 1 from each of these. So this would be 4. This would be -1. This would be -6, -1, and this would be -6. So what does this look like? Well, down 1. Down 1 is easy enough to handle. And I usually start here, just like I told you last time. I start here. Now I know I'm moving left 2. So I'm starting at -2. Right, I was going to go 0 to 4. I'm moving left 2, so I'm going to start at -2 and go to +2. So -2, -1, 0, 1, 2. I've got everything I need. Maybe extend that. All right, I've got everything I need there. I go as high as 4. So I go as high as 4. I go as low as, I'm going to have to add a couple. Let's just say -6 is down here. All right, I go as low as -6. And so what do I do now? I am going to put these on here. All right, so what do we got? We're going to go starting at 4. So starting here, I'm going to go to my high point. Then I go to my midpoint, right? We're back at 0, or -1 in this case, because that's -1. And then down to my low point at 0. So I'm going to be down here at 6, then back to my middle and up to my high point. So this is going to be a very stretched graph. That's going to go down through here. Whoa. Drawing on a tablet is not easy with these. And then going this way. So you have that. That's a really ugly graph of it. I should try to smooth that out. All right, still just as ugly. All right, so those are our key points. I expect to see these key points. That's about as bad as it could get, guys. That's an ugly one. But you have to take it apart piece by piece and try these. And again, try them. Don't just skip them. Try working through these, okay? That's it, guys. Good luck with this. I will answer all your questions. We'll draw every one of these tomorrow. All right. So, well, I should say we'll go over every one of these if we need to tomorrow. All right. Have a wonderful day. See you in class.